today we are very active in providing data annotation services for AI projects, including natural language processing projects. So I will be telling you more today about how to structure your specifications in order to get good annotations that you will then use to train your models and achieve, of course, good performance. So to start this discussion, I want to highlight that I will try to make this webinar not too formal. I want to make concrete examples so you can really project yourself and see what I'm talking about. In addition to that, as Kai mentioned, we want this event to be interactive. So don't hesitate to ask your questions on the chat. And what I suggest is that if there's a question in the chat that relates directly to what I'm talking about, one of the organizers can feel free to kind of talk to me and tell me that there's a question, because I cannot see the chat in direct. Okay? Don't hesitate. So this is the agenda I propose for today. First, welcome and introduction. Then I will explain to you why you should build your specifications for annotation. And we'll then deep dive into the 10 most important framing questions to build your specifications. This is based on our experience, and we were able to take a step back on our experience in order to define these 10 questions, which to us are very key to make sure that we have good specifications for us to provide good annotation services. And then, of course, the open discussion, we can have a chat after this presentation. And of course, there's the open discussion at the end of this meetup. So I've already introduced myself. So I think it is okay, but maybe to add something to what I said is, well, I'm trained as an engineer, but also have an MBA. And my job today is to basically build the methodologies to deliver good annotation. So I spend a lot of time thinking about that from a general perspective, but I also work together with our clients in order to build custom data annotation pipelines for them to receive good services and for us to obviously meet or even exceed their expectations in terms of quality of annotation. So why should you build your specifications prior to annotation? Let's start with a use case. Of course, this is just I would say an abstract use case. But for example, you have a hotel chain in Hamburg, and you want to know what to improve based on feedback that you receive through the booking platforms. The booking platforms already provide you with some stats on how your staff is performing, how is the comfort, how is the free Wi-Fi, things like this. But what exactly should be improved? And the thing is that you do not want to read each of the hundreds of comments that have been received in order to identify what should be improved. So maybe a good idea would be to develop an NLP model that will be analyzing the client feedback in order to understand the services that are discussed into the comments, the solutions, or what elements, the equipment that is maybe has a problem or that is very good, the staff, what is the sentiment of the comment, is it negative, neutral, positive? And then the question is, how do you translate that? This is something very important we'll be talking about today. It's about the end user of the model who has a need. I want to understand comments on booking platforms. Okay, how do we translate that into engineering specifications? This is the role of these of the specifications, and this is what we'll be talking about today. And the aim, of course, is, for example, to build a list of classes for running the predictions with your NLP model, and also more related to annotation. How do you select named entities? What are the risks? What expressions mean the same and stuff like this, so your model performs well. Okay. So focusing on the translation part, the idea is that converting expectations from a client to engineering specifications and to satisfying deliveries is very complex. This is a fairly general drawing that is fairly famous, but it really highlights the differences in language and the way they can be interpreted all along the value chain of the data. And it is very important to make sure that we transform this situation into a situation where we have a common language, where we perfectly understand each other, and where we make sure that we satisfy the data scientist who is going to use these data annotations to train their model, and at the end of the day, the user of the model, okay? Another constraint that we have to deal with data annotation is that when a data scientist develops one model, the data annotation company or the partner or the person who will be annotating the data has to do that thousands of times. They have to annotate thousands of texts, meaning that if you have something that is a bit ambiguous or even that is wrong into the specifications, this error will be repeated thousands of times. And of course, this will create bias into your model. So we have to really make sure that they are perfect. And we also have, in this situation, to introduce some concepts which are more about industrialization of a workflow. Talking now, you can see it at the bottom right of the screen, about model accuracy. When we translate a need into specifications, we also have to put that into the context of what are the expectations in terms of accuracy. And one question I want to ask today is, okay, when you develop a model, what accuracy do you target? Are you targeting 99.999%, 98, 80%, or do you want it to work sometimes? Of course, this has a lot of impact on the solutions that will be developed and deployed to annotate data. It is not the same to ask for 99.999% than 80% quality, all right? And most of the time, the answer to this question is it depends. It depends on the projects. Why does it depend? Because it depends on the way you will be using your model. Do you want your model to work in a fully autonomous way? In this case, there is no supervision at all once the model is deployed and an error might be more critical? Or are you going to have someone to just check some recommendations and then make decisions by themselves? The criticality is not the same. True positives, which is obviously the most important target, are actually only one part of the KPIs. What do you do if your model detects something and it's actually wrong? What is the price of a false positive, and what is the price of a false negative? This is a very important point. And in addition to that, I would add that in addition to the actual performance of the model, you have to take into account the perceived performance of the model by the end user. The reason being that if there are some very basic classes for your model to predict, there are some of them that you just cannot miss, because if it is missed, then the end user will say, okay, this model doesn't work at all. It doesn't even recognize this, you know? For example, talking about the example with the hotel chain in Hamburg, if they do not recognize bedroom or something that is talking about the bed or the comfort in bed, the perceived quality of the model will be very bad, even though it is perfect for everything else. Okay? Then how do you measure this quality? How do you measure the true positives, the false positives, the false negatives? And what do you test your model with? Of course, the performance of your model, you have to test it in order to measure it. But the way you test it and the data that you use to test it has a lot of impact on the performance you see from the model. Again, if your model is performing very badly on bedrooms, if you test it with only data that talks about other rooms in the hotel, then it will seem to work perfectly, but actually not. So quality, it depends. It depends on the project. It depends on the end user and the end use that is going to be made of the model. It depends on what are your metrics. And what I want to highlight today is that it is the same with data annotation. What will be quality annotation? it just depends on the project. So this is one main point that needs to be remembered. As I mentioned before, we have also to introduce industrialization into the data annotation pipeline, because when we develop one model, we have to annotate thousands of data points. I don't know how familiar you are with these concepts, but at INGEDATA, when we develop data annotation pipelines, we have to talk about FMEA in order to anticipate and mitigate risk. We have to talk about quality assurance. We have to talk about how we are going to control quality if we introduce sampling into the quality control system. And how do we sample that? How do we make sure that the samples that we use are representative of the whole batch of data that has been annotated? Because at the end of the day, what we deliver to our clients, who are basically data scientists or companies who have data science teams, it is the comfort and the serenity of making sure that the data set is well annotated. Because then, if they have an issue with their model, they know that they can have trust in the data set, and they know that what's inside the data set, and they know where to look at if there's an issue or if they have to improve the performance of the model somewhere. So today, of course, this is the whole methodology from starting to talk to a client to delivering, and even going further than the first deliveries of data annotation. But today, we'll really focus on this first part, which is highlighted in yellow, which is converting the voice of the client into specifications. So the objective is understand client needs, and the deliverable at the end of this step is specifications, which is a concrete deliverable that is made to the client. Of course, then the clients have to review it to make sure that they are totally okay with what is said, and that we are all aligned on the specifications. So when we discuss that with our clients, we always look at things from a specific point of view, and this is the point of view of these 10 most important framing questions. We really want to make sure that each of these 10 points are well addressed into good specifications. Of course, depending on the specificity and the complexity of the project, each question doesn't need to be tackled in the same way or with the same effort. So this will be your role to ask yourself, okay, in the context of my project, to which extent do I need to answer this question? If you have, of course, a very complex project, loads of budget, you can go very, very far into that. If you have to get a very quick delivery for a simple project or something like this, then of course you don't need to go as far. So let's go into these 10 most important framing questions. So those are the questions. We will discuss them one by one. What I want you to understand is that the 5 key points is to provide your annotation partner with good project understanding, with rules on how to classify, how to segment the data, how to handle ambiguities, because of course, if we annotate thousands of data points, we cannot anticipate everything that is going to happen, or any case that will appear in the data set. So we have to know how to handle ambiguities, and this is the discussion about reject and edge cases. And finally, we have to put this whole thing into project success context, which means that the plan needs to fit in terms of quality, KPIs, and planning. It is very easy to deliver the best quality if we have 2 years, but in real life, a project needs to be delivered in more time usually, and it's important to take that into account when developing specifications and when launching a data annotation pipeline. So first of all, the project understanding. This is just to make sure that you adopt a common language with your annotation partner and with the team of annotators that will be dedicated to your project. The aim of that is, first of all, of course, they need to understand how the model will be used. using the same language for you to exchange information, and then they will be able to become more agile and proactive, meaning that by being agile, they will react better to situations, edge cases typically, and they will become more proactive at like making recommendations for you to improve the way annotation is made, because at the end of the day, they are the ones who are gonna see every piece of data in your data set. So it's very important to make them able to feed you back on that and comment and say, okay, we have seen this and that, and this is new, I didn't expect it, and maybe you should add a new class, maybe you should think about it. So this is very important. You need to build a relationship with the annotation partner and to make sure that they understand the project. It is not enough to say, okay, I want to detect that, please annotate anything that is talking about that, because then you are missing a lot of value. Talking concretely, we have been working about an NLP project, and this is a bit similar to the use case of the hotel chain in Hamburg. This is why I chose it in the first place. This is a real project, though, where we have had to annotate a data set of client feedback on cars. So basically, our client had loads of data on cars and feedback from the end users, the driver of the car, about a specific car. What we have been doing is annotating the sentiment, either negative, positive, or neutral, the type of system that was involved, and the type of service that was provided in the comments. So for example, we have a use case here. Audrey had just bought her brand new car. It was beautiful, comfortable, but she couldn't mount her phone onto the cockpit. She needed to use Waze navigation system, but she could not just plug the phone into the ventilation system of the car. And this is a typical type of comment that you can find online, but for which the engineering teams in charge of designing the ventilation system would not know about. So it was very important that we build together a common understanding on what are the different systems in the car, what are the different services in the car, for the annotation team to work according to a taxonomy that talks as well to the end user of the car, but also to the engineering team of the car. So this is what I'm talking about when I'm talking about context understanding and common language. Now that we have been talking about the project understanding, let's see how to classify. We defined the definition of the classes to be followed to provide annotation services in 3 blocks, 3 stages, which I will be discussing today one by one. So first, define what your model needs to predict, then potentially add metadata to it, and finally add to that business constraints, okay? So the first part, what your model needs to predict. Of course, when we have to annotate, we need to know what are the different classes for the project. And this is very business-led. Our client need to talk to the end user or maybe to check literature on potential projects that are similar to it in order to start building a list. What do I need to detect into the texts? Okay, so list your classes. And then you have to define them. Explain what is every class within this list and try to objectify it and to provide examples. This is the first thing. Okay, let's take another concrete example. We have been working on a project which is about the analysis of tweets, and it is about defining emotions. Emotions is highly subjective. It is very difficult. And the issue we were tackling, okay, we have to annotate and say if it is sadness, if it is anger, if it is anticipation, fear, any type of emotion. But okay, how do we make sure that we perfectly understand and that we objectify a task that is initially highly subjective? And using literature, we have been able to identify some previous work that was made by a psychologist who is named Plutchik, who defined key emotions, and who also helped us defining what emotion is what, and in which case, how to classify the tweets. So first step to define what to classify, a list of classes clearly explained, defined, objectified, and for which we have examples. Okay. Second thing is I will explain to you what I mean by metadata, because of course, when we send annotations to a client, it can already be considered as metadata, but I will explain what we mean by that. We have a list of classes, okay, but this list of classes might not be enough for you to know what's inside your dataset. I will explain myself. You have to make sure that the dataset that you use to train your model is homogeneous and representative of a range of situations that are basically representative of real life. And in real life, there's slang that is used in text. There are acronyms, there are typing mistakes, bad spellings, idioms. And it might be interesting for your project to add some metadata, for example, to identify how many idioms you have, how many slang words you have, how many acronyms, so you know what's inside your dataset. Even though you will not be using these classes to train your model, at least you know how homogeneous and how representative your dataset is when you train your model. Okay. Another very concrete example, which is not about NLP but computer vision, is about face recognition. There have been studies on face recognition models. The annotation task is only about positioning landmarks on the face of the people, but actually a very interesting metadata to add to this project will be the ethnicity of the people who appear in the images, because in the first place, we noticed that the computer vision models were performing much better on lighter skin than on darker skin. And this is not right, because it doesn't represent real life. So adding metadata on the ethnicity, or whether it is light skin or dark skin, is very important to make sure that it actually represents real life. This is another case about chatbot improvement. So our client deployed a chatbot to provide client support. This was for luxury fashion, a large company. And well, people were basically able to ask typical questions on chatbot, like where is the nearest store? What are the opening times? Do you have this type of garment in this color? Things like this. But the situation was that they did not know how far the chatbot was able to go, and they did not know if the chatbot received some inquiries for which they did not have a good reaction planned for it. So what we did is that we reviewed and kept annotating discussions and inquiries that were received on the chatbot in order to, one, do a scoring task, which was about scoring the point where the chatbot stops being performant. For typical questions like where is the nearest store, it is very easy and the chatbot will be performing well. But when the conversation keeps going and when questions become a bit more tricky, then the chatbot performs less. And it was very important to understand the time when it stopped performing well. Second thing was to identify new types of inquiries for them to be aware of it and to develop the model according to this type of inquiries and to keep satisfying the end user of the model. Last part on how to classify is the business rules. I will explain to you. So the idea here, and it is true mostly in the context of multi-labeling projects, the idea is to try to add gatekeepers to the annotation task. So so you make sure that annotators make the right decisions. For example, we have to annotate text on types of products, and we have to understand, for example, the name of the product, the color, and the size. Once you have decided that the color of the product is red, then a business rule will tell you if it is red, then it cannot be blue or black or green, right? So then we are able to add these kind of rules to make sure that we add some gatekeepers and who are used for the annotation task. Maybe we know that a specific type of bag, let's say a small handbag, cannot be in size XL. So in this case, once we have decided that it is a small handbag, then you do not have the rule, the opportunity to put XL as a size, and you reduce the number of choices to be made by the annotator, and you make sure that it completely matches with what happens in real life, with the business rules that are behind. So once we have the three blocks, we can believe that we have well translated the research on what is the model gonna do into a list of classes. So you have defined what your model needs to predict with a list that is defined, objectified, and for which you have provided examples. You thought about adding metadata for you to know, for example, how many acronyms, how many slang words there are, how many expressions there are in your data. And finally, you have potentially been able to add business constraints to make sure that you have these gatekeepers to make sure that the annotations that are made are really relevant with your business. Once we have that, we are in a very good situation to understand how to annotate the data. In the context where we have to segment elements of text, it is also very important to decide together what will be the segmentation rules for that. For example, do we have to include articles or not? Do we have to consider words that are completely made up by someone, the writer of the comment or the writer of the text? What about an expression that is into iPhones and it's actually not used in real life? All these are segmentation rules to make sure that annotation teams know what they should consider as a representative example and what they should not. And for example, if article or not should be included into the segmentation task. Now that we know the project understanding, how to classify and how to segment in terms of entity recognition, then we have to anticipate how the reject and edge cases will be mitigated. How do we tackle that? Because again, if there are thousands of data points to annotate, we cannot anticipate everything, and we have to kind of embrace the situation of having an uncertain workflow where situations can happen. So how do we handle them? The idea here is to work in a dynamic manner to reduce as much as possible the area where edge cases can happen. So together with the life of the project, the idea is to keep working on it and to, using examples, make sure that the annotation team is aware of what should be considered as a reject case or what should be considered as a valid case. And the best way to show that is really providing examples of edge cases. So it's important to show examples of cases which look valid, but which are actually not, or the contrary, they do not look right, but they are actually very valuable for your dataset. To that, we can work with a certainty scoring system to make sure that annotation teams are able to, kind of score how certain they are with the annotation they provide, to make sure that the quality control that can be done after the annotation task is focused on the most complex cases, the most ambiguous ones. Okay, so this is very important, and it has to be handled in a dynamic manner because events happen. Okay. Finally, about project success. As I explained, we have to put all this into context. So now that we know what needs to be done, it's important to clarify how far we need to go in terms of quality. In some cases, our clients are very happy with 80% quality of annotation. In other cases, they really need 99.999% quality. So this has a lot of impact on the solutions that we will be deploying. On our side, we have a toolbox, and we are able to cut it out and to use or plug together different types of processes in order to best match the efficiency and quality expectations for the project. But we have to know what are the expectations for the project. So this is about it. Talking about quality, the first thing is to know how you will be measuring the quality. For example, we have an named entity recognition project where there is a segmentation task on some specific parts of text, plus a classification task according to a list of classes. Do we consider the whole text as the level to which we'll be measuring quality, which is basically the lower level? Is it a pass or a fail? Or do we start making a bit more effort to get more information? Is it the segmentation or the classification that was wrong? And actually, was it a false positive or was it a false negative? Was it something that we annotated but which shouldn't have been, or was it something that was very important but that we missed? You know, we can start having a little bit more information, and at the end of the day, we can even go down to calculating precision and recall performance on annotation. I'm not talking about the recall and performance metrics for the model prediction. I'm talking about the annotation. Okay, so of course, having more information is a lot more valuable for us to understand what is the root cause of the problem and for us to solve it. However, it does represent more effort, and we have to make, there's a trade-off there, and we have to find the right balance. Another leverage that can be used is to use sampling, as I mentioned before. So when we do quality control, in order to measure, okay, how many passes we have, how many fails, how many false positives, false negatives, and things like this, we can use sampling rules in order to make this effort a bit lighter, but still to get a lot of information on the quality of the data. This is a concrete example on a document classification task. This was for a large video gaming company who had loads of past documentation on past video gaming projects, and they needed, for knowledge management purposes, to develop a classification model that was able to classify the documents in order to say, okay, it talks about how to make the sound of an explosion. It talks about how to design the hero of the video game. It talks about this and that and blah, blah, blah. Because they were then able to reuse it for new video gaming development projects. And it was very useful to them. So in this context, we had to tag documents with people who provided knowledge in video gaming, because these documents are quite complex. And we faced a situation which is the following. we faced a situation where at the beginning, INGEDATA was very, very good, twice better than the expectations of the clients in terms of recall performance. We were very good at recall. However, the situation was that in terms of precision, we were not quite there. We only achieved 80% of the KPI. We were at 67% precision, and they were expecting 85%. So there were too many false positives. The fact of being able to have this level of detail in terms of quality performance, knowing how many false positives, how many false negatives, how many true positives we have, knowing the recall and precision performance, we were able to make modifications to the annotation workflow that we're using in order to meet both targets. Basically, very concretely, we changed the workflow so false positives were reduced by 70%. It did have an impact on false negatives, who slightly increased. But at the end of the day, and this is on the right of the screen, despite the fact that the recall performance decreased a little bit, we could then grow significantly the level of performance of precision. And in this way of working, we're able to meet both requirements for recall and precision performance. Okay? And this is also an example on how we sample, how we build samples of data for quality control. It is based on an ISO certification. If you are interested in this matter to make your quality control processes more efficient, I recommend you get a look into that, which it is called the ISO 2859. And it is about basically making sure that statistically the samples that you randomly extract from your annotated data are representative of the global quality of the dataset. There are a few things to acknowledge when you do that. First of all, you have to commit to a quality acceptance level. You have to say, okay, what I want is not 100%. What I want is not the best possible. What I want is 98%, for example, something that is quantified. And second thing is that you have to accept that if you want 100% confidence on the fact that 98% of the quality is reached, then you will have to check everything. You have to accept that if you work with sampling, then your level of confidence will be slightly lower than 100%. It will be 90, 95, 98% confidence. And of course, the statistical rules that apply to extract samples from the annotated data depends on this level of confidence. How much risk of receiving a wrong batch of annotation are you willing to take? And of course, how much risk is your annotation partner willing to, how much risk of having a rejected batch while it was actually right? How much are they willing to take? So this is a discussion you have to have with your annotation partner, and then you are able to implement sampling rules for quality control and to significantly reduce the time that you spend double checking the annotations, and potentially you are able to trigger more exact information on the quality of the data for your annotation partner to be able to react better to situations and to identify the root causes for a problem in annotation. Finally, the planning, because again, having a lot of time is very different from having short time, and usually we have to understand how to work in a short timeline. What I want to highlight here is that the time that we have to deliver annotations has an impact as well on the solutions that we'll be deploying. So at the top of this screen, you have the situation where we have more time. We are more in the complex of a recurring project. where we'll be able to capitalize on the learning curve of the annotation teams for them to keep growing and to keep adding levels of complexity in the annotation tasks. Second scenario is that you need us to work on a more complex project from day one and to be operational very, very fast. In this case, we will implement. We know that we cannot capitalize on the learning curve as much as in scenario one, and we will deploy another solution which is basically based on task division, where we will build within the team smaller squads of people who are very specialized into one thing. So, for example, going back to the examples on the hotel chain in Hamburg, maybe we can have people, a squad that is specialized on client satisfaction regarding the staff, other people who are specialized on client satisfaction regarding the equipments, people who are specialized on client satisfaction regarding the general comfort or the location of the hotel or things like this. And by making sure that they are very focused on a smaller thing, they will become experts of this smaller thing, and they will become they will be able to deliver high quality a lot quicker. So, providing your partners with more context on how much time you have to get the data delivered is very important for us to then deploy the right solution. This is a concrete example. It's also about the classification of tweets, but in this case, it's not about emotions. In this case, we are talking about a quite complex project because it's talking about geopolitics. There is a number of tweeters who have authority in terms of geopolitical comments or news, geopolitical analysis, and we developed a team who was in charge of tagging these tweets for an NLP model to then be trained at classifying tweets automatically. What we started with is, let me see if I can, okay, I can show you here. We started with phase A, which was basically a starting point with existing tweets and existing intelligence to be extracted from these tweets. And the first question was very easy because we're at the beginning of the learning curve. Does it have geopolitical interest or not? And it's actually a tricky question because depending on the context, a situation can have geopolitical interest or not. If, I don't know, the US develop a new partnership with Russia, then a situation in some parts of the world will be completely changing, and something that initially didn't have much of a geopolitical interest starts having a lot of geopolitical interest. So then it is a tricky question we first focused on. Once we were good at that, we started adding new types of tasks, new types of data sources, in order to add, for example, information on, okay, what location are we talking about, or what type of actor? It is happening in France and the actor is Germany, for example. This is another type of task that we were doing. And then, again, by monitoring the learning curve and detecting the plateau of the team, so, okay, they start working on the task, then they grow, they become better and better and better until they reach a plateau. When we reach the plateau, it is the time for us to grow the complexity of the project. So this is the time where we'll be adding a new task. And okay, let's start adding a new task, which is the tagging of crisis factors. Okay, what type of crisis factor is it? Maybe it is about oil and gas. Maybe it is about COVID-19. What is the situation connected to? So this was a new task that we added. And today, together with the learning curve, we have been able to deploy even more complex tasks, and we are able to know on a very high variety of authors, sources, languages, the geopolitical impact or interest of a tweet, who is involved, where it is happening, and what are the crisis factors. It can be oil and gas, it can be COVID-19, or it can be many other types of situations. And we also became a lot finer in terms of annotation complexity. What happens if something is happening in the German embassy in France? Are we talking about Germany, or are we talking about France? What is the location, for example? This is a type of situation. In terms of a source, we had to identify as well whether it is a political statement or not. But what do we consider as a political statement? What if it is a statement that is made by someone of authority, but who is not a politician? And who do we consider to have enough authority to be considered as someone of authority? When I say something on Twitter, do we consider that I have authority? If I talk about the COVID-19, do I have authority? Do I have the same authority as if I was talking about data annotation? So all these are subjective matters that were implemented with time for the team to grow together with the learning curve, and for us to add more complex information to be extracted. Another example, for example, about the locations. Of course, locations can be a country. This is an easy case. But what if we are talking about ISIS territory? Do we consider that ISIS territory is a location? This is the type of questions that we have to handle. And this is the reason why building good specifications is very important in order to get good quality of data annotation. So now, I don't know exactly how much time we're gonna spend on the Q&A session before having the open discussion at the end. But of course, don't hesitate to ask your questions.
Yeah, so I'm really surprised there's still 29 persons here in this audience who were so fascinated as I was by all the tasks, and still didn't start watching Champions League on television, but kept in this talks. So I really thank you all for listening. And I mean, if there aren't any further questions here, we would like to suggest to start the discussion in our Slack, or if you don't want to join the Slack, in the forums and the comments of our Meetup section. So I think all those thoughts here were so interesting that we should definitely follow up and discuss them further. I would really like to do that.
Thank you all for joining. I'm also very happy you've all stuck around. You've all participated in the discussion, and thank you very much to our presenters tonight for those fascinating talks. I think, yeah, we've all had a long day, and I look forward to seeing you again on Slack and maybe interacting with you and talking about, I don't know, character embedding based models on that. So join up, and until then, just thank you very much. It's been a pleasure listening to you and interacting with you.